In this video, we are going to talk about repeating decimal numbers or decimals. Yesterday, we talked about terminating decimals. Now we're going to convert repeating decimals into fractions. I would like you to get your guided notes and follow along. So in this video, we are going to talk about repeating decimals. What are repeating decimals? These are numbers that have decimal points in them that goes on and on and on and on. As they go on and on and on forever, there are some digits in the numbers that are being repeated, or there are patterns that are being repeated. And we know it is a repeating decimal. It is pretty obvious because of the bar that they place on top of some digits. And these are the digits that are being repeated, just like these examples in front of you. So these are the numbers that we are going to change into a fractions. Yesterday, we changed terminating decimals into a fraction. It is very easy because the denominators are all powers of 10. The number of digits in the terminating decimal number is the number of zeros at the denominator of the powers of 10. But when we change repeating decimal into a fraction, we are not going to use powers of 10 as denominators, but we are going to use denominators like 9, 99, 999. And when will we have a denominator of 9, 99, and 90, 999? Let us take this example. 0 point with a 0.7 with a bar on top of 7. Oh, this is a repeating decimal. So what will I do to be able to convert this into a fraction? Write the decimal point as a whole number, meaning to say no decimal point, no bar on top. So that would be 7. Okay. Next, over. How many repeating decimals do we have? 1. That is how many number of nines that are placed at the denominator. Okay. Now, always, is this my final answer? Can I simplify this fraction? What goes to 7 that can go to 9? Nothing. So this is the equivalent, this is the equivalent of 0.7 repeating as a fraction, 7/9. Okay, we're good. Now let us try to have another example. What about this one? 5.072. The decimal places over there that are being repeated are 0.072. Let us set aside the whole number for a while. Put it aside. Now let us change the decimal places into a whole number. We have 72. We are not going to write the 0, right? There's no need to write the 0. And over. How many repeating decimal places do we have? 3. So that is how many number of nines that go into the denominator. We're good? Okay. Next is, can we simplify this fraction? Now, this is a rule of thumb. I'm going to give you a shortcut. Let us try to divide the numerator and the denominator by 3 because only 3 is a possible factor of 9. So if I will divide the numerator with 3, is it possible? Oh yeah, that is equal to 24. If I divide the numerator by a 3, I will also divide that by a 3, which is equal to 333, right? Okay. Hey, look at your denominator. It's 333. I can still divide that by a 3. If I divide the numerator by a 3, I should also divide that. If I divide the denominator by 3, I should also divide the numerator by 3. Whatever you do to the numerator, you have to do that in the denominator. In the same way, whatever you do to the numerator, you have to do that also to the denominator so that you will not change the fraction. So 24 divided by 3 is equal to 8, and 333 divided by 3 is equal to 111. Is there any GCF between 8 and 111? Nothing. So we are done. Meaning to say, this is the equivalent of 0.072 as a fraction. Now, is this my final answer? No, we need to bring this back. So 5.072 repeating in decimal number, it should be equal to 5 and 8 over 111. These are equivalent expressions. One is in decimal number, one is in fraction. Repeating decimal number into a fraction. Okay, if you need to go back to this video to fill up your guided notes, to do the rest of it, I highly recommend that. If not, if you need help, go to your seatmate. If not, come to me as a last recourse. Okay, so you pause this video. I would like you to try this together with your friend. If you need help, don't hesitate to call me. And after accomplishing the whole guided notes, I would like you to go, not a Delta Math, I'm going to give you another paper in as much as we do not have computer yet. And then you have your mastery check in your guided notes. All right?